We've seen how we can classify chemical reactions by what the products are doing, what state the products are in, what kind is it, gas evolution, is it a solid precipitation reaction. But here we're going to learn to classify chemical reactions by what the atoms are doing. So we can have a synthesis reaction in which we have one product. At the end of the day, what you need to remember about synthesis reactions is we end up with one product from two or more compounds. Decomposition reactions are the other way around. We get one product, it breaks down into two, or one reactant that breaks down into two or more products. For a displacement, sometimes known as a single displacement too, you have the reaction involves one atom displacing another and replacing it in that compound. So here you have A come in to this compound and kick out the B and take its place. Double displacement is where we've seen for precipitation reactions where we have a swap. So A will go with D on the outside and B will go with C on the inside. So outside cation and anion combine, and inside cation and anion combine. Let's go ahead and do an example. Here we have one product, so this is key to saying that this is a synthesis reaction. Here in B, we have an exchange of anions and cations. So the barium went with the sulfate and the potassium went with the nitrate. So this is looking like a double displacement. Okay. Here in C, we have the aluminum going with the oxygen and the oxygen being kicked out on its own. So it looks like a single displacement. Okay. Here we have one product that breaks down, or one reactant that breaks down into two or more products. So this tells us that it's decomposition. In E, we have one product coming from two or more reactants. So that means it's a synthesis. Okay, go ahead and give this a try. Classify each reaction as a synthesis, decomposition, single displacement, or double displacement. For A, it looks like we have aluminum coming in and taking away the phosphate here, and the hydrogen gas being kicked out. So it looks like it's a single displacement. In B, we have copper combining with the hydroxide here, and we have potassium combining with the sulfate. So it looks like an ion exchange of both cations and anions, so it looks like a double displacement. Here we have one product coming from two or more reactants, two in this case, so that means this is a synthesis. Here we have the opposite. We have one reactant, because it's on the left side, giving us two products. So it looks like it's a decomposition reaction.